So we're gonna start by doing the particular, the complementary. So that's y double prime plus y equals 0. So we get r squared plus 1 equals 0. So we get r to equal plus or minus I. So that means y complementary is sines and cosines. C1 sine x, because we've got complex, plus C2 cosine x. And from here we can derive the u1 and u2. No? First, get the Wronskian. So let's do it. Okay. So that's sine x, cosine x, and their corresponding derivatives. So cosine x, derivative of cosine is minus sine x. And then we take the determinant of this. So this is minus sine squared x minus cosine squared x. So that's minus into sine squared x plus cosine squared x, which is minus 1. Okay, so we've got the Wronskian to be minus 1. So now we go to our u1. So u prime 1. You're there, Ben? Is minus y2. So this here is y1. And this here is y2. So minus y2 times g, and g of x is this guy right here. It's the secant x over the Wronskian. So we plug them in, so minus cosine x secant x over minus 1. So that will get us 1, because cosine times secant is 1, because secant x is 1 over cosine x. So if we integrate both sides, we get u1 to be the integral of dx, which is x. So u1 equals x. And now we go to u2, or u prime 2. U prime 2 is y2 times g over the Wronskian. So y2 was cosine x y sine and cosine. y2 is cosine. This is y1. Is sine x times secant x over 1 minus 1. Okay, so that's minus sine x. Secant is 1 over cosine x, so that's minus tan x. You can either do it with use substitution, or if you remember what the formula is, you could use it. If I do it using substitution, something like this, Ben, you should know how to do by now.
Yeah.
Cosine x dx, this is a very simple integral. Cosine x is u.
Oh, yeah.
So u equals cosine x, which means du equals minus sine x dx. So this becomes u2 to be minus du over u, because sine x dx is minus du, and we have a minus here, so this just become a plus du over u, which is ln u, and our u is nothing but cosine, so this becomes what's that?
Oh, no, you're right. Yeah.
No, because the denominator is the u.
Yeah.
So it's ln cosine x absolute value. So u2 is ln cosine x. So now that we found u1 and u2, our y particular is nothing but u1 y1 plus u2 y2. So that is u1 is x, y1 is sine x, plus u2 ln cosine x absolute value times y2 cosine x. And in that case, y general is y particular plus y complementary. So this is c1 sine x plus c2 cosine x plus x sine x plus cosine x ln cosine x. And now, this is y general. We can use the initial conditions that we have in the problem to solve for c1 and c2. So we are told that y of 0 equals 1. So plug in 0 for x, so we get 0, or we get y is 1 equals 0 plus c2 plus 0 plus cosine 0 is 1, ln 1 is 0, so the last one is 0, which would give us c2 to be 0, to be 1. And now we are told further that y prime of 0 equals 2. So let me get the y prime. So y prime is c1 cosine x minus sine x, because derivative of cosine is minus sine, and c2 turned out to be 1, plus product rule on the x sine x, so it will be 1 times cosine x plus 1 times sine x plus the first as is times the derivative of the second, plus product rule on cosine x ln cosine x, so minus sine x ln cosine x plus cosine x. Derivative of ln cosine x is 1 over cosine x times minus sine x. So these two go away. And now y prime is 2 when x is 0. So this will be c1 minus 0 plus 0. Those two go away anyways. Plus 0 minus 0 because sine 0 is 0. Plus 0 or minus 0, either way. So c1 equals 2. So c1 is 2 and c2 is 1. Therefore, our y general is c1 sine x, so 2 sine x, plus c2, so plus 1 cosine x, plus the complementary that we got, x sine x, and the last one is cosine x ln cosine x.
How do you get cosine ln cosine?
How?
Yeah.
Because when you integrate the minus tan, you get ln cosine.
Yeah. Yeah, so that's I got that. Then where the other cosine?
Because in the particular, it's u1, u2 times y2. Y2 is cosine.
Yeah.
That's where I got it from. Okay, man. Oops, this is x sine x. Yeah, x sine x. Just copied it wrong. So 2 sine x, cosine x, x sine x, and cosine x ln cosine x. That does it for this problem.